Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So I'm going to talk about how to find the inverse of a 2 by 2 matrix, okay? So it's very important that you review my previous video, especially how to find the determinant of a matrix. So because it's going to be very, very key to understanding how to find the inverse of a 2 by 2 matrix. So go back to the playlist, search for determinant of a 2 by 2 matrix or a determinant of a matrix. Try to watch the video. I think I did a 3-part video for that. So try and watch it, try and understand before moving on to this, okay? So before I forget as well, don't forget to like, share, and subscribe. And if you've not clicked the notification bell, I don't know what you're waiting for, so that when I post new videos, you'll be the first person to know. All right, let's get into this now. So just like any other number, every number has a reciprocal. Does that make sense? So for instance, if you have 18, all right, so let's go. If you have 18, we can have the reciprocal of 18. So reciprocal, all right, reciprocal of 18, that will be 1 over 18. And when you find the reciprocal of 1 over 18, that will still give you what? 18. So every number has a reciprocal, right? So similar to an inverse. So basically, it's the same principle that we apply to as well in metrics. So if a matrix A, okay, now what happens is that when you find the inverse of matrix A, it's going to give you A inverse. Are you seeing it? And when you find the inverse of A inverse, it's going to give you back to what? Matrix A. So that's what we have, what we're talking about here. So when you find the inverse of a matrix, so it's going to give you the inverse of that matrix. And when you find the inverse of that matrix, it's going to give you the original matrix as well. Now, there are two things that you need to keep in mind while doing this, that there are two major requirements, okay, for you to have an inverse. The first one is that the matrix must be a square matrix. So it must be like a 2 by 2 matrix, a 3 by 3 matrix. But in this example, or in this case, I'm going to only stick to a 2 by 2 matrix, but it must be a square matrix. So no matter the type of square matrix, you can find the inverse. And also the determinant of that square matrix must not be 0, okay? So I'm going to write down the two requirements here that has to be fulfilled before you find the inverse. So the two requirements, okay, to have an inverse. So the two requirements to have an inverse. So the first requirement is that the matrix must be a square matrix. So the first one is that the matrix must be a square matrix. So like I said in the previous video, when we say square matrix, we mean that you have the same number of rows and columns. So when we're talking about the order, so you have the same number of what? Rows and columns. Okay. Now, number two is that one other thing you need to know is that the second requirement, like I said, is that the determinant of that matrix must not be 0. So the determinant, so we talked about the determinant in the previous video. So you need to also know that the determinant of the matrix must not be 0. Okay, all right. So before you solve, make sure that these two requirements is fulfilled or are fulfilled first before you now start solving. Now, I'm going to just do a quick reminder of what we call invertible. I mentioned it during when I was talking about matrices, and I'm talking about determinants. So I told you that a singular matrix that has an inverse is called invertible or non-singular, while a matrix that does not have an inverse is called singular. So I mentioned it during the introduction of determinant, and I told you that I'm going to talk about it here, all right? So I'm going to write it here again, just for emphasis. Okay. I'm going to write it here again, just for emphasis. So a singular, or let me say a square matrix. So a square matrix that has an inverse. So remember I told you that this inverse only applies to square matrix, right? Now, but when you now find a square matrix that has an inverse, it's called non-singular or inversible. So it's called invertible, okay? Invertible or non-singular. Okay? Non-singular or invertible, all right? Now, but when a matrix that does not have an inverse is called singular, all right? So when a matrix that does not have an inverse, so if, for instance, you check the matrix does not have an inverse, this is called a singular matrix. So I also mentioned the singular matrix when I was talking about the types of matrices in the beginning of this video series. So it's the same thing here. So while a matrix, all right, that does not, or let me put this in, maybe I can put this as the next one. So I can say a square matrix that now this, in this case, does not, all right? So the keyword now is that it does not. So have an inverse is called a singular what? Matrix. Okay. So if it has an inverse, it's called non-singular. If it does not have an inverse, it's called what? Singular. Now, so a matrix does not have to have an inverse. So not all matrices are going to have an inverse, but if it does, the inverse is going to be unique to that matrix. Okay, so not all matrices will have an inverse. So some of them might not really have an inverse, but if a particular matrix do have an inverse, is the inverse is going to be unique to that matrix. Okay, so I'm going to write this down. So a matrix does not have to have an inverse, but if it does, okay, the inverse is unique. Okay, so when you solve for a particular matrix and you get an inverse, that inverse is going to be unique to that matrix. Okay, good. So like I said, in this video, I'm going to only focus on how to find the inverse of a 2x2 matrix. So I'm not going to do 3x3 in this video. You can go back and solve that on your own, but because of the audience I have, I'm going to restrict myself to the 2x2 matrix. And how do you find a 2x2 matrix? So what I'm going to do is I'm going to write down the rules for this, okay? So the first thing I'm going to do is going to do the 5 rules. All right, so the 5 rules for finding the inverse of a 2 by 2 matrix. So 5 rows, or you can call it the 5 steps, anyone you want, okay? So the first thing you have to do is that you have to find the determinants of the 2 by 2 matrix. So in the previous video, I've talked about how to find the determinant. So it's very important you do that, okay? So go and watch the video and know how to find the determinant of a 2 by 2 matrix. So the first thing is to find the determinant of the 2 by 2 matrix. Okay, so I told you that if, for instance, a matrix A is equal to A, B, C, D, so I told you to find the determinant, okay, which is going to be that A or A in absolute values format is going to be, you're going to become A, you're going to multiply A times D minus B times C. So we've talked about this earlier and I've solved these questions already. So please go back to my video playlist and get that. So number 2, the next thing is that you have to then divide the answer, divide 1 by the answer you have in step 1. So the next one is you have to now divide 1, okay, by the answer you have in step 1, or with the answer. I think that will, or divide 1 using the answer all right, from step 1. Okay, so that means in this example, so step 1 is going to become 1 divided by the answer you got, let's say, for that A. Are you seeing it? So you're going to divide that, it's going to give you that. Number 3, okay, I'll take this up a bit now. The next step is to then rearrange the matrix by doing the following. So the next step now, you need to listen carefully. You have to then rearrange the matrix. So you have to rearrange the matrix by doing the following. Okay, so the first thing, okay, you have to swap the elements in the leading or main diagonal, all right? So the same thing, you have to then swap the elements in the leading or main diagonal. So remember, so if you have A, B, C, D, all right? So I told you then that the leading diagonal is this. This is the leading diagonal. So the elements you have is A and D. So what we are now telling you now is that we want you to swap it. So what you're going to have, you're going to take D here. Are you seeing it? And you're going to bring A here. So basically that's what they want you to do. So the first thing you have to do is to swap the elements in the what? In the leading what? Diagonal. All right, so so we've done that, we've rearranged. So now the second step that you need to do, let me take this up a bit. Now, after rearranging it, the next thing you have to do is that you have to then swap the signs in the other remaining element in the other diagonal, okay? So what we are now saying is that you have to swap the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. Okay, so you have to then swap the signs. So step the other two, you have to then swap the signs of the other remaining So you have to swap the signs in the other remaining elements in the other diagonal. Okay, so now if you look at this, so the other diagonal, so what we have, so we have A, B, C, and D. So the other elements in the other diagonal we're referring to B and C this time, okay? And from the previous one, we've already agreed that this is D and this is A, right? So what we are now saying is that you have to swap the sign. So now if this is B plus B, it's going to be minus B, okay? And if this is C, it's going to be what? Minus what? C, okay? Now, but one thing you need to know is that if, for instance, assuming, all right, let's assume that we have something like this. Let's say we had A minus B and we had C, D, all right? Now, the first step we told, we're going to swap the elements in the leading diagonal. So it's going to become D and A, all right? Now, in this case now, since we're swapping the sign, this is negative, it's going to become positive, and this is positive, it's going to become what? Negative, okay? So I'm just assuming, giving an example to show what I'm trying to explain. So no matter the signs you have there, you have to swap it. So it's going to be positive for negative or negative to positive, all right? Good. So that's what I want to just say. So let me just clean this so that you will not get confused with that. Now, the next one is we go to step 4 now. So number 4. Then you have to then multiply the final rearranged matrix from step 3 with the answer from step 2. So finally, the final rearranged matrix now we have, this is the final rearranged matrix. We have, this is the final one we've gotten now. From step 3 with the answer we get from what? Step 2. So this is the answer we got from step 2 here. Are you seeing it? So we're going to multiply this one, the answer we got here, with the answer we're getting here. Is that okay? So we will then multiply the final rearranged matrix from step 3 So we're going to multiply this now with the answer from step 2, okay? Okay, so what I'm saying is you then have 1 over step 2. We had that A. We then multiply this now by the answer we got from step 3. We have D minus B minus C and A. Okay, so you can then write this again as 1 over, or you can write it determinant of A, or you can write the absolute value of A. It depends on what you want to do. Determinant of A, so multiply by D minus B minus C and A. Are you seeing it? All right, so when you're done with that, so we now go to number 5. Step 5, which is the final and the most interesting one. You then simplify, all right? So that means basically you open the brackets like we normally do. All right, so I'm going to pick an example here to just explain, and then you can go to the textbook and pick as many as you want and you can play around with it. So let's pick an example quickly, all right? So the first one, we have example A, example 1, or so example. So we're told if A is equal to, all right, we have it as 3 minus 2. We have it as 5 and 1, all right? We're now told to find A inverse. So this is A inverse, right? We're told to find A inverse. Now let's go quickly. So step 1, what is step 1? In step 1, we are meant to find the determinant, okay? We're meant to find the determinant of the 2 by 2 matrix. So let's go and find the determinant of the 2 by 2 matrix. So step 1. Okay, but to find the determinant, so that A will be equal to 3 times 1 minus 5 times minus 2. So that will give you 3 times minus 2, and that will give you, it's going to be 3 minus 10. Minus times minus will give you plus. So it's going to be 3 plus 10, and that is going to give you what? 13. So that A is equal to what? Determinant of A is 13. Now, when you're done with that, step 2 now said that we then have to divide 1 using the answer from step 1. So we have to divide 1 using the answer from step 1. So what we have to do in step 2, we have to then divide 1, the answer from step 1. So step 2 now, okay, we have to then divide. So it's going to become 1 divided by the answer we got is what? 13. So you're going to get 1 over 13. Now, step 3, which I believe is that we then have to rearrange the matrix. So we have to swap the element in the leading diagonal, then we have to change the signs. So step 3 now, let's go with step 3. Okay, so step 3, what do we have? We had, so we knew A was equal to, what we had was, well, let me clean this one. So the element we had, so we're going to swap. So what was it? We had it to be 3 minus 2, 5, and 1. So we have it as 3 minus 2, 5, and 1. So the first thing you do, like I said, we then have to first, the leading diagonal. This is the leading diagonal. So we have to swap it. So it's going to become 1 and 3. All right. And after swapping it, then for the other one, we have to then change the signs there. So minus 2 will become 2, and 5 will become minus what? 5. Are you seeing it? There, so you're going to have 2 and minus 5. Then step 4, we're now told that we then have to multiply the answer from step 2 with the answer from step 3. So it's going to be 1 over 13 multiplied by 1, 2, minus 5, and 3. So 1, 2, minus 5, and 3. And step 5, which is the final one for this, is that we have to simplify. So step 5 is that we have to what? Simplify. So remember I told you when simplifying, so if you have K into brackets, we talked about this earlier, A, B, C, D, all right? I told you that it's going to be, you open the bracket with this, it's going to give you KA, multiply K with the other one, it's going to give you KB. Is that making sense? Multiply K with this one, it's going to give you KC. Talked about this earlier in the previous videos, okay? So this is going to give us KD, all right? So we're going to apply the same thing. So we have 1 over 13, right? It's multiplying 1, 2, minus 5 and what? 3. Okay, so it's going to give you 1, 2, minus 5 and 3. So let's see. So we have 3. Okay. All right. All right. So we're going to open the bracket now. All seems to be in order. So we go. So this one is the whole, is multiplying each of them. So it's going to multiply this and this. So 1 over 13 times 1. And this is going to give you 1 over what? 13. 1 over 13 times this is going to give us 2 over what? Give us 2 over 13. 1 over 13 times minus 5 is going to give us minus 5 over what? 13. And 1 over 13 times 3 is going to give us 3 over what? 3 over 13. And that will be the final answer for the determinant. So therefore, we can now say the determinant for this question. What was the question again? Was it A or B? What letter? A, okay? So the inverse for A, so therefore now we can now say that the inverse, all right, A inverse was equal to 1 over 13 minus 5 over 13, 2 over 13, and 3 over what? 13. And that is the answer for that. All right, so that is it. And I hope that you understood this very well. And if you have any question, please do let me know, and I will try as much as possible to respond to you. You can send me an email, and my email is on the platform, so you can send me an email and I'll respond to you as well. All right, so the next video I'm going to talk about is how do we solve simultaneous equation using metrics. So we also use metrics to solve simultaneous equation, and that is why it's very important for you to subscribe and click notification bell. So when I post the next video, you'll be the first person to know. All right. Thank you very much. So I'm going to see you in the next video where we're going to talk about how do we use metrics to solve simultaneous equation.